Good afternoon. We have a couple things left to do before we take our next test. One is word problems, which I'll cover with you tomorrow when I get back. The other is the conjugate root theorem. And hopefully we're familiar with the word conjugate. We've used that a lot throughout the year here. We're going to use it today to write polynomial functions of least degree, just like we did for our last test, and I'll show you an example of that in a little bit. The main new thing to note is that if you know a root or a zero, right, that's what we've been finding in the last couple of days. If I said we looked at our calculator, where does the calculator hit the x-axis? It hits at 2. That means that 2 is a root or a 0. That's our answer. Well, you might find that you actually have not rational roots like 2 or -3 or a half. You might have ones that are imaginary or in irrational form. And if they are imaginary or irrational form, they come in pairs. Okay, so that means if I tell you that 2i is a root, you have to know that -2i is also a root. Likewise, if I give you these are called radicals within the roots, that's a radical. If I say square root 3 is a root, you have to know that so is -square root 3. So that's really only going to be the only new thing today is to know that if I give you either an imaginary or an irrational like that they come in pairs. You have to give the opposite, or I should say the conjugate, not necessarily the opposite. Because let's say I gave you one with 1 plus root 2. You wouldn't give me the opposite of that. You'd say the conjugate is, well, then 1 minus root 2. That's the conjugate. You switch the sign in the middle. Okay? So let me remind you where you were, where we've been, and show you how that applies to what we did today, or what we're doing today. Where we've been is, in the last test, I asked you to write a polynomial function of least degree that had 3 zeros. They weren't necessarily 2, -2, 3, but that's a similar example. So you guys remember how that worked? Okay, well, hopefully you're thinking a little bit there. How it worked was, if 2 was a 0, then x minus 2 was a factor. And if -2 was a 0, then x plus 2 was a factor. And if 3 was 0, then, what's the last one? X minus 3 is a factor. And you weren't supposed to leave it in that form. I think some of you did, unfortunately, but you weren't supposed to. You're supposed to multiply it out. Now, you're going to have to multiply twice. So you want to make sure, you better make good decisions today about what you should multiply. What you should multiply are conjugates when you have them. And these right here are conjugates. X minus 2 and x plus 2 are conjugates. And we like to multiply those out because the middle cancels out. So I'm just going to multiply that out. You'd have x times x is x squared. -2 times 2 is -4. The middle stuff would have canceled. The 2x and the -2x, that would have dropped out. So we don't need to put that when we have the conjugates, and we're multiplying conjugates. So now I have to take x squared minus 4 and multiply it by x minus 3. And it was just boiling x squared times x to the third. X squared times -3, -3x squared. -4 times x, -4x. -4 times -3, +12. That was the answer, except for I would like you to put f of x in here so it then truly is a function. Put f of x equals. That's where we've been. We've already done this type of problem. Hopefully this was a good reminder for you. You're going, okay, got it, let's move on. So we turn the page over. Now I give you a very similar type problem, only it's got either imaginaries or irrationals. The first one has an imaginary. It has a 3i. You have to know that since there's a 3i, then that tells me there is at least one more root, and that other root is negative 3i. So we're going to take each of these roots and write the binomials that go with them. A little bit different looking here, but same idea. If 3i is a 0, then x minus 3i is a root. Or a factor, I should say. 3i is a 0, it is a root. But x minus 3i is a factor. Then I would use the negative 3i next. If negative 3i is a root or a 0, then x plus 3i is a factor. Finally, you also have the 4 there. Don't forget about that. If 4 is a 0, then x minus 4 is a factor. So now we're going to multiply these out. It's the same what we did on the previous example on the previous page. It's just you've got these i's. We multiplied i's in first semester, so I have the faith. You can do this. These are conjugates. There'll be no middle term. All you need to do is x times x is x squared. And negative 3i times 3i, careful here, negative 3i times 3i. What does that equal? Well, some of you might be saying negative 9i squared. Some of you might be saying plus 9. They're the same. We do want to change it to plus 9. So when I multiply those out, I get x squared plus 9. The middles would have canceled. Had I done this, x times 3i, I would have got 3ix. And negative 3i times x is negative 3x. They go away. So that's what's nice about these. They look ugly, but if you do them right, the middles cancel and it's not so bad. Then we just need to drop down our x minus 4. I'm going to put f of x equals, and we FOIL that. X squared times x is x to the third. X squared times negative 4, negative 4x squared. 9 times x, 9x, and 9 times negative 4, negative 36. There's our function of least degree that has zeros at 4 and 3i, but it would also have a 0 at negative 3i. And I hope that makes sense to you. It's to a power of 3. That tells us there's how many zeros? 3. And there they are. Okay, a couple more. Number 2 does not have an imaginary. It has the irrational. But it's the same deal. If I tell you negative root 5 is a 0, then you got to know positive root 5 is a 0. And I would put those together first. So I've got 3 zeros. I'd be inclined probably to say, all right, if negative root 5 is a 0, then what's a factor? X plus root 5. And if root 5 is a 0, what's a factor? X minus root 5. Finally, if 5 is a 0, what's a factor? X minus plain old 5. Okay, we're going to multiply the conjugates. Some of you are probably trying to do this on your own at this point. That's fine. Just make sure you check back in after I'm done here to see that you have the same answer. If not, I'll just continue at the same pace for those of you who want to follow along as we go. X times x is x squared. Middles are going to cancel because these two things are conjugates. Root 5 times negative root 5 is negative 5. The square root of 25, but that's 5. Drop down the x minus 5. And then FOIL it out. Don't forget your f of x in front. X squared times x is x to the third. X squared times negative 5 is negative 5x squared. Negative 5 times x is negative 5x. And negative 5 times negative 5 is positive 25. Anybody has a question, you could certainly pause this right now, and then somebody, I'm sure, can clarify in the class. So make sure if you have a question to say, can you pause and take a break and let somebody explain to you what's going on here. Okay, make sure you check this answer. Hopefully you all got it. Finally, we'll do the toughest one of the bunch, which I will warn you is just like one on your test. On your test, you're going to have one that has both an imaginary and an irrational. You got to know that since 10i is a root, so is negative 10i. Let me write them like this. So I'm going to have a 10i, I'm going to have a negative 10i, and since root 2 is a root, so is negative root 2. So this is going to have what degree? If you said 4, you are correct, because it's got 4 zeros. So you should end up with something x to the 4th. Let's set up our factors. The first one would be x minus 10i. The second one has a 0 of negative 10i, so it's going to be x plus 10i. The third one, x minus root 2. And the last one, x plus root 2. Now those who struggle end up trying to multiply, say for instance these two things. That ends up being really ugly. You don't want to do that. Make sure you only multiply the conjugates. Okay? So, the conjugates are the x minus 10i and the x plus 10i. Oh, hang on a sec. Well, I'm going to go ahead and leave it. It's got covered up. I can't get rid of my, hopefully get rid of this, so I'll have to erase a little bit there. Alright, so what I want to put together is these two. Then I want to put together these two. Then, after that, I'll take those two new answers and put them all together. Okay, so make sure to multiply the conjugates. X times x, x squared. Middles will cancel. What's negative 10i times positive 10i? It's a negative 100i squared. So that turns into x squared plus 100. Again, if you're working ahead fine, just make sure you check your answer when we're done here. Over here, x times x is x squared. The two middle things will cancel because they're conjugates. What's negative root 2 times positive root 2? Well, it's negative root 4, but hopefully we know that's just 2. Root 2 times root 2 is 2. Okay? Alright, we just got to FOIL these two binomials, and then we're done. X squared times x squared is x to the 4th. X squared times negative 2, negative 2x squared. 100 times x squared, the 100x squared. And 100 times negative 2 is negative 200. Wouldn't leave it like that, why not? If you're saying or thinking you've got like terms, you got to put them together, you are correct. The x squared should go together to make 98x squared. With the minus 200 at the end. There is your answer for the least degree polynomial that has the given roots. Okay? So hopefully this made sense to you. You'll have a worksheet of these to work on. Again, the one on your test will be just like the one I just did, so make sure you understand. I'll probably see you at the end of the hour. If not, have a great day. See you tomorrow.